So everyone, hello back on Friday night.
Hi, Jungwoo.
Yeah,
Hi, Hi, Antonio.
Rhino
Goran.
101 class. So first things to do, yeah, in Beam World, Rhino. We continue. Well, today everyone is avatar. Looks nice. Let me share my screen. If you can see, let me know.
Yeah.
Okay. So
Yeah, we can see it.
that's good. So last week we were doing a little bit of 2D tool using hatches and line weight printing PDF, and we also talked about sections, how to draw a section in Rhino, and yeah, we looked at some extra title block, like let's say the viewport we can add to put the drawings there. We'll do more detail in terms of scaling, scale factors, and organizing your drawing sheet and etc. But generally, we did our 2D basics, and also we looked at the surface tool, how you can create surface. And today I'm going to show a little bit more surface editing tool that we can. We don't have to do everything, but some simple things. So let me just draw some line here. Probably I'll just draw a rectangle. Okay. And from there I'll use this extrusion tool and extrusion straight. I'll just extrude something like that. And we are in the shaded view mode. And first thing, fillet surface, the command. Fillet surface, we can set the radius of your fillet factor. And we can choose two surface, and as you can see, that's the fillet of the two surface. Let me repeat. To repeat, you can hit mouse right button and you can find the command history, and from there you can choose the command, or you can just simply hit enter or space that it repeat your previous command. And now what I'll do, I will do here, for instance, instead of radius 1 meter, I'll make it 50 centimeter. And there are different options. Maybe we can go this option. Let's try first and second, and you get this smaller radius surface fillet. Okay. Now, simple, yeah. Actually, a lot of them I also don't use it. So let's see. There is also extend surface. So extend surface. So select an edge to extend. Probably I'll scale, like I'll explode this surface, and let's scale 1D. There's a command called scale 1D. Scale 1D means one directional scale. So I can put scale, we can choose anchor point, and then the end point of your geometry to scale. And I'm gonna scale a bit down here. Let me disable some of the snap functions. And now let's extend surface. So select an edge to extend. We can select this. And extension point, set base point. We can just say base point here. Base point. Basically, we can just stretch it. And once we stretch it, yeah, basically you can stretch it. It's nothing different than scale 1D. Actually, I don't know why we need this tool, but yeah, looks like. Okay.
Yeah.
When you have a surface which intersect each other, for instance, here there is an intersect edges, you can split also, type split like a line. You can split this surface against that one, and you get the splitted surface. Okay, it's very simple.
Yeah.
And the chamfer surface is just simple. You can do the chamfer. I think you can set the distance of chamfer or extend it, trim or not. You can choose. If I do trim, no, I don't know what result we get, but let's see. Okay, basically you get the chamfer but not trimmed surface. Okay. In this case, if you want to trim, you can also do trim, and then I think we have yeah, There is no trim surface, but you can, I believe you can just type trim, and we can select all of this. Let's trim. Yeah, you can trim even though they are surface. Okay, so this command for trim is not only works for 2D, but it also works for 3D surface. Okay, which is very handy. Nice. And yeah, chamfer, we did variable reduce surface. So this is like you can fillet variable surface fillet, which means like I can choose in here, and you can, you know, change the with this gripping. If you select, then you can type the number. For instance, here let's say 0.8, and you can click on here, and you can type to 2 meter, and you see you preview, and when you hit enter, this is like result of your variable fillet. But I think let me go back. The command, let me go back, and variable surface 1 and 2, and here the trim option should be yes, trim and join. Then when I finish, the radius was, sorry, one more time, radius was same radius at the time. So I'll go here, just control drag and drop, make it like different, a bit differently, and yes, then you can get this result. This is also nice, yeah. And there is also blend surface. So we have here one surface. Are you guys with me, by the way?
Yeah.
Okay.
Yeah.
Just in case I'm away from the internet. So we have these different edges. We can blend it. So we can select first edge, second edge. When you blend, you can see we can control this blend option. First and second. You can also set different position for that. I don't know. We can set tangency, curvature, G3. I don't know what all these terms means. Actually, Rhino is really mathematically well organized, and a lot of options you can have. So blend surface, you can get this kind of result, which a lot of case ordinary BIM software cannot do, but Rhino simply can generate this kind of geometry very easily. That beautiful surface. And you can also F10 while you are selecting, you can select this control point, which means this control point can be manipulated up to you. Yeah, like this is already such a nice surface geometry, you can imagine. And right now I don't see any ISO curve. It's because I turned on that ISO curve option from the settings. So if I turn on ISO curve, you can see there's ISO curve goes all the way. Okay. And you can also put flat shading if you like, or shadow. Then you can see the shadow of the surface in your shaded view mode. I just turn it off for the performance. Alright, so offset surface, which is really important. You can click and select surface to offset, and you can give the distance. For instance, I can go 1.5 meter, 1.5 meter, and which direction you can choose. And if you want both direction, you can say both side. If you don't want, you can, and you can flip the direction which direction to offset. And if you want to make it solid, means when you offset, it becomes actually solid geometry. It's no longer surface. Yeah. But if you let me undo, and then if you go offset surface, I don't want to make it solid. And when you say now, then you actually offset the surface. Is that clear for you?
Yeah.
Yeah. And while you have surface, I'm gonna show you some selection option. If you hold your control key and shift key, you can select the edge of surface or vertex of the surface, and from there you can also change it, manipulate your surface. Okay. Again, control shift, and you can select the face as well. While you're selecting face, and if you use your gumball, it is a dot point, and if you If you move it up, then it's basically extrusion. Yeah, extrusion of surface. Very nice. I'll go undo. So let's go ahead, offset. The others are not very interesting, but probably we can do variable offset. And here now, if you set all right now 1 meter, but let me undo. Add handle, you can add offset handle. Means from here, there, and from this point you can control your offset value, you know. So when I eventually finish it, while we are offsetting it, we can get this kind of geometry, which is crazy nice. I don't know, but I don't know, and I'm an architect, you know. And we can go to see rendered view to see how typology looks like. Yeah, beautiful. So we are keep doing surface tour. Any question?
Until now, no.
Until now, no. Yeah.
Clear.
Yeah, I think the others are it's like as it's written, match surface, merge surface. It's very common. Connect surface, symmetry, and etc. We're not really gonna do that. Maybe we can show this one. I'll offset surf, and I'll make maybe 5 meter offset for this, and we have such an offset. So we have two different surface. And when you do twin between two surfaces, and I'll select first surface and surface, and then I'm gonna give sample number. So number of surface I want to create 3 or maybe 5, and then you can choose different settings. And when you finish it, as you can see, we have this kind of it's not the exact offset surface, but it's twin surface in between first and second. Okay. Which is nice, actually. Some idea for MEP, Antonio?
Well, maybe for some complex elements that we do not have from supplier.
Yeah.
To edit the family and put it in there.
Yeah. Exactly. To me, it looks something like very nice shark. Shark, the breathing part of the shark, or something. Yeah, looks nice. Okay. So the other rebuild surface is also nice. So we have, I'll copy this there. When you do rebuild, we did it already a couple of times, and you can simplify this typology, and we can make the degree. Let's make it degree 1 to 1 degree, and maybe I'll make it like this kind of typology. Yeah, I'll delete input and hit OK. We can get this simplified surface out of it, which is also very nice. So you have like a total freedom of surface geometry in Rhino. And here, if you do, you can also do the curvature analysis, like where is the higher curvature and where is lower curvature. You can see. You can just turn it off. You can change to mean, which is minimum radius or maximum radius, things like that. But yeah, it just gives you extra information of your surface modeling. And if you want to check the reflection of this surface prototype, then you can go to here, surface tool, and when you look at the environmental map, you can turn it on for this surface, and you can choose what kind of environmental map you want to provide. You can see here, when you do fluorescent map, you can see the reflection of surface, yeah, how it will reflect it. You can also change to, for example, if you are jewelry design, I don't know, polished silver, you can see. So that's the kind of silver if it's silver material, you can see this kind of reflection. I don't know if you go to gold, yeah, it's nice. Here is very nice if you design jewelry. If reflection is really like that way, I don't know, you can make something nice. Okay, so you can end when you close, then it close. So on the surface tool, when you go here, analysis tool, you have environmental map. Okay, there are so many analysis tool in Rhino, but just simply we just check the surface prototypes, yeah, how it reflect or like coverage of the surface and etc. Okay, I think that's pretty much it for creating surface. There are so many tools, but I just you play with yourself, like, because there are so many. Yeah, maybe drape is also could be interesting. You can say set the spacing between them 10, and you can we can set the surface that you want to drape, and this just draping the area, and when you bring it, you know, like basically you put the fabric on the geometry, and what you get is this kind of geometry. It's also could be interesting design. Okay, so next thing we wanna do, when you come here, this let me use the tool I like. So when you come here, this one, it's very nice tool here. Basically, you can extract curve lines out of your surface geometry. So I'm gonna click on here, and we have like many of them here. So first of all, what I want to show, you can duplicate face border. This one, duplicate face border, means if I click on this surface and hit enter, and now you see we duplicate the face border of this surface. Sometimes it's very useful. Let me try again this prototype, and you get this kind of silhouette, let's say. Yeah. And the next, another one, duplicate border. What is different? This actually, I don't know what's the exact difference between duplicate border and duplicate face border. Let's keep it. I usually duplicate border for this kind of typology, but I guess duplicate face border is more related to. Actually, we can go help menu. If you go help topics. No, sorry, that's not good. Help, command help. If you put on, and when you put that command, usually auto command help comes, and it explains what exactly this command does. So the duplicate face border command create a curve that duplicates a polysurface face border. So if there is a polysurface, we can get actually this kind of face border. I'll show you now. I got what it means. So right now we are working with single surface, but let me copy this surface, and I'm going to join them. So once you join them, they are becoming polysurface. Okay. In this case, if you use this tool, duplicate face border, you can select like the face of this polysurface, and then you can duplicate whichever you select. Whereas this duplicate border, you can basically duplicate entire like this border of the whole polysurface. I think that's the difference. And again, I've never seen any software is so helpful in terms of their help menu. I never seen as good as Rhino help menu. So when you do command help, whatever you click, Rhino shows immediately with a short video most of case, and shows the steps, and you can just simply read, and you can actually run all this tool pretty much without any searching for YouTube or something. You can pretty much run from here. That's actually how I run Rhino when I start Rhino back in 2004. Since then, they always have this nice help menu. Alright, then here duplicate edge is also nice. So you can select and you can duplicate edge of the surface. Okay, you can basically extract out here. The others I'll do like, and here you can extract ISO curve, which means when I select one of these, you can choose U or V direction, or you can choose both direction. If you choose both, as you can see from UV, this ISO curve, you can extract U and V curve at the same time. I'll repeat. And if you choose just V direction, then you can see you can extract only one V direction. Yeah, you can extract as many as you want. So that's extract ISO curve tool, and we did extract wireframe last week. So when you do, then you get all the wireframe of the surface. And then there are many more object intersection could be interesting. So I'll copy this and put it here, and I'll rotate it a bit, and we create some intersection between the surface. And if you use this object intersection, then when you do it, you get the intersection line. You see, which is also nice. So that's the intersection. The others I don't use much. Yeah, there are so many silhouettes, and probably contour is nice tool. So let me copy this one. And if you use contour tool, you can select, and you have to assign where you want to start from, and how much distance. So from I select here from up, and the distance in between I'll make 10 centimeter. Then it create contour every 10 centimeter. The selected geometry, I gave the vector direction, just basically z-axis, and you get this contour line every 10 centimeter. I'll try again. So this time I'll define maybe another direction, not just that, and maybe every 5 centimeter, and you get this kind of contour line. Okay. It looks like I already designing some kind of shoes or something. Already a lot of process we did. Oh, that's the rest. I don't know. There are so many useful tools, or yeah, maybe projection is also could be interesting. Let's say we have this surface. I'm gonna draw from the top view. One of this surface. This is most complex surface, so I'm gonna draw one circle from the top, and let's bring this circle up. I was in the wireframe view, shaded view, and now I'm gonna project this one circle. Project, and there are different options, but I'll just do in Z direction. It's basically just projecting this curve on this surface, so we get this kind of projection curve. What could be useful, you can split. For example, I can split, then this split surface you can delete it, for instance. Okay, let me copy, undo, split, and copy this one next, and I'm gonna isolate these two guys. Isolate, and instead of project, I can also do pull curve. So curve, select curve to pull, and then enter, and I can select surface to pull. Nothing happening. There was something happen, but it's so basically pull is a little different than just projection. Projection is you just project one directional projection, but the pull is a little bit different definition. So that's why the result is different. Maybe I'll scale a bit smaller and move it a bit and repeat the command. And now I'll do surface, and when you get Yeah, I don't know. I don't actually remember exact definition of pull, but again, when you go help, command help, and when you do pull, then it shows what pull. Okay, so it goes every normal direction, and then based on that, this curve is pulled to the surface. Somehow like that. So it's actually scaling down. I think this geometry was a little bit too complex, but let me move it a bit to the simpler geometry. Here, for instance, and if you pull the curve surface, yeah, you see the result somehow. You can clearly see the difference between pull and projection. Project. Okay. You guys with me? All good? Hello? Okay, so bottom line, let's say, I'll do it again, this tool one more time, and you come to standard and this tool here, which is basically you can get the lines from surface, extract lines, and you can also project and so on. So bottom line is that here if you see duplicate border, which means you can duplicate at the border of surface from that, yeah, with single surface. But when you have joined, which is no longer single surface, we have poly surface, then in this case we can use duplicate face border. If you use this tool, we can choose the face of the poly surface, and then for example I want to extract two face border, hit enter, then this is the result you can get. Okay. Whereas this duplicate border for the poly surface, when you click, hit enter, it will just extract the border of your poly surface. That's the difference. Okay. And there is a duplicate edge you can select, and you can just duplicate the edge of your geometry. So for instance here, which is very useful. So this command here, they are very useful when you want to continue to work on some kind of geometry. And here, extract ISO curve. You can select. You remember ISO curve is UV line of your surface typology. So when you click, you can choose V or U direction, and you can extract the line from that. Or let me repeat. You can choose to both direction, then you can get the both UV direction of your surface, and you get the line. Okay, that's very nice. Why it's important? Probably you see if I repeat and instead of both, I'll get the V direction. Maybe I'll get the turn on midpoint here. Then you get like the V direction of surface UV, you get it, and you can maybe split it, then you get two surface. There is direct tool you can, without extracting curve, you can split that, which I'm gonna show you later. But anyway, this kind of extracting curve is useful when you have to keep modifying your surface. Okay. And we did last time this extract wireframe. So when you select, you can select the one of the surface, hit enter, then you can extract the wireframe of that. You see? We did it last week. So these are all, it's very handy, this Rhino command. And let's imagine you have like this intersected surface, and you want to get intersection line of two surface. Then you can use this intersection, object intersection. Select object to find intersection, hit enter, and you see this is your intersected line of both geometry. Okay, very simple.
Yep.
What could be very interesting tool is like this contour tool. What it does, you can select one of the typology, and then you can give the direction from starting to which vector you want to give. For me, I want to give directly to up, and let me give 1 centimeter to create contour. Then it creating contour line of this particular surface towards the vector I gave with a certain distance. So this every 1 centimeter we get this kind of contour line. Which could be interesting. For instance, let's say we have such a complex geometry from whatever software we import in Rhino, and I want to draw another contour from here to up, and I want to give every, let's say every 1 meter, I want to give contour line, and this one probably I'll extract as a facade. Extract as a some kind of, I don't know, whatever, or maybe you want to piping them. Select curve. I mean, maybe you pipe it, something like that. As kind of facade element.
Yeah.
Alright, so that's the contour. We had wireframe, extract, wireframe, intersect. All the others are not very interesting, I guess. And you can also draw section line, which we did. Silhouette you can get. Yeah, nothing particularly interesting. But there's interesting point between projection and pull. So projection is basically you can project particular curve to the construction plane, in this case C plane Z axis, so you get this projection. Okay, and pull is a little bit different. So Rhino help command is really useful when you click on pull, and it shows how it works. So basically it calculating every surface normal towards this curve, and then the curve is pulled to the surface. So it's a bit of scale factor, as you can see. Okay. So if I do this case here, then depends on surface prototype, it pull based on the normal direction, and it's just somehow calculating this kind of, relationship, and it's just pull on surface. That's the pull command. I think that's all. I mean, why we use this, because you can keep modifying your surface. For instance, once you project, you can split that curve, and you can maybe take it out, and from that edge line, maybe you extrude it, I don't know, whatever. You can keep modifying your geometry. We have run here, for instance, fillet surf, so we can give the fillet vector between them, and you can maybe fillet it, but for that relationship we may look more detailed in solid geometry, because the solid fillet works better. Okay, now we catch up what we lost from internet disconnection. So I think you got all the info from this particular tool, what you can extract from surface, and how you can continue the geometry. Any question, guys?
All clear.
All clear?
No, clear. This is very, very useful, especially in architectural and structural part.
Yeah.
Because maybe I'm not idea if there's some concrete organic shape, not irregular, that you can easily get some line approximation, or if there's some facade to get under construction, and looks very nice.
Yeah, for this kind of project, for example, like what kind of project would be useful, I'll show you maybe as a reference. Yeah, Maxo. This is one of the projects I was working on, and okay, it was eventually documented in Revit, but wow, that's really complex facade, yeah? But look this part here, like this part. Yeah, this kind of shading elements could be nice. And this project is realized actually. Let me actually find the realized project image. I don't know if that is real image. Yeah, here we go. It's built. Something like that. You see?
Yeah.
Yeah.
It's an apartment. And on the top is a penthouse. That's the rendering, but it's really built in that way. Yeah, anyway, just short. So that this kind of geometry you can do it, and you send, Revit. Back then we had to use Rhino file import, SAT file import, and then the facade was really crazy. Yeah, but eventually creating this kind of thing in Revit. Do you know software called AutoCAD Athena? Athena?
No.
This is AutoCAD application. I guess it's a Swiss-based company, but this software is crazy. Why it's crazy? It's you can go do the facade detail, really crazy detail, with this tool very easily. Like, I can show you, and it's full parametric. It is AutoCAD based, but fully parametric. Yeah, they don't really focus on marketing, but you have just cut and grid lines, and then you define this profile of your facade, and it's just creating the custom mullion directly, which can be very complex geometry, and then it keep updates. Like, it's really good system. It based on your CAD detail, and it really creating a really final detail, and then eventually you can export as IFC file directly from this software, and then you can link into Revit. I think that's how we worked in this particular project, because it has really LOD like 400 details, really big, higher level of detail in this project. All right. Anyway, so Rhino can be very useful for complex project, yeah.
Yeah, that's right.
Mm.
I like this piping tool.
Piping tool, yeah. Piping is just very simple. You can just type pipe, and then you can, give the diameter, and you can pipe it, or you can pipe, and instead of sorry, you can also give there is different pipe tool. Let me type pipe, multi-pipe, not multi-pipe. Yeah, I think pipe tool is correct, but multiple. If I enter, it's only one. That let me chain edges. Let's see. You can change the pipe diameter, start and end. I think you can also, just start and end. But there is a variable option. You can also put in between, and you can keep piping. Let me try again this one. Pipe. First one, this, and then we can select shape local end, and we can give also another control point in the middle, or wherever you click on, and you can make some kind of crazy pipe. Hit enter. Yeah, this is like nice. Can you think about this kind of MEP, Antonio?
Yeah, usually it's the same diameter, and then a reduction or transition piece.
Yeah.
But yeah, it can be used.
Can be used. Yeah. I don't know, because Rhino also used many different industry, even medical case, and they really model or medical equipment, like somehow if it has to be like that, yeah. So it could be useful.
Yeah, like connectors.
Connectors, yeah.
Yeah.
For instance. All right, I think we have 10 more minutes. My question is, should we go to solid tool or not? Maybe we can go. So let's look at solid tool. So solid is very simple. We can create like a box geometry, you know, or from the box we have different like method of drawing box. Okay, very simple. And we have also like a cylinder you can draw. You have a sphere, cone. You have a torus, like, you know, donut shape, and all these kinds. But when it comes, what is solid in Rhino? Actually, this is not really solid. I'm gonna change my layer and I'm gonna type special command called clipping plane, which you can define the clipping plane. And when I move this plane, you can see this is like a dynamic section, kind of. And this clipping plane, you can rotate it, and based on rotation, it will also give you different clippings, kind of. It's not section, but it just clip the geometry. Okay.
Mm-hmm.
And as you can see, let me go back. As you can see, this is the solid object in Rhino. When you type what, this is called just extrusion. But let me explode it. If you explode it, then you see there is now they became single surface. When you join them, then it has iso curve, but it's different. Now it's called polysurface. You see? But this is extrusion. And now if I use my clipping plane, move it down, and as you can see, these between extrusion and polysurface, it looks like a solid, but actually they are empty, you know. It's not really filled in with something. But it's Rhino particular. If you see here, you know, this surface, polysurface that has empty gap. But in this case, solid geometry doesn't show. It looks like a completely filled in. But in reality, if I explode this one, then as you can see, it's not really, you know, solid. It's so in Rhino there's no. Okay, if you say in Rhino solid means let me delete now. It means there shouldn't be any naked edge. So when I go back to surface tool, on the surface analysis here, we can click show edges. Okay, and I'm gonna select all the geometry to display edges. And when you turn on naked edges, and you can choose the color and you can zoom particular ones, but as you can see, solid object here, they don't have any naked edge. Naked edge means it's the edge of the single surface basically, or poly surface which is not completely enclosed. Okay, so let me give you another example. I'm gonna join all this except one of the face, and this face I'm going to turn on the control point. Let's move like minus 0,0001. Yeah, in our eyes it's really like, if I turn off this if I turn it off, you never when I type what, it's polysurface, you will think this is like completely solid. But if you analyze it, add object, and you can see there is naked edge. Yeah, they are not joined completely. This kind of typology, when you now use clipping plane and then you move it, you can see there is difference. This is not filled, completely filled, but the others are filled. So solid means in Rhino, it's basically you don't have any naked edge and it completely enclosed poly surface, let's say. When you have any small gap, then it will recognize as a just poly surface, which is not really solid. Do you get what I mean?
Yeah.
Yeah.
So this analysis tool, naked edge, is very useful when you work with surface, or you can turn it off. And when it's solid object, then it becomes interesting, because now if I go, for instance, editing solid object, we can use fillet edge, and here we can define edge where how much radius you want to give, and of course we can preview it. And if you finish, that's the preview of your fillet edge. So you can completely fillet this kind of solid. Because if you do for the surface, let me explode it, and then if you do fillet surf, then after result you get result, but you have this kind of extra surface which you have to split or look after continuously later, which is a bit of extra work. But when it's solid, you can work with this kind of fillet edge. Fillet edge, and you can keep the wherever you want to keep fillet, and you can work with it. I mean, to creating this kind of geometry, let's say one of the software we common use is Revit. It's still difficult to create. You have to make an extrusion, and then you have to use void geometry that you cut it out and couple of operation. But in Rhino, you can just simply do it, and it's already done. And maybe you need to create this kind of object. I don't know. Depends on what you do. Rhino inside is now working in Revit, so you can convert this kind of thing as a family immediately. Okay. I think today we're not gonna do further for the solid, but we'll continue next week. By the way, next week I have to skip because there are friends visiting. Maybe we can arrange it to another date if you're okay.
It's okay. We'll find.
Yeah.
During the week we'll find.
During the week. So let's finish today here. Any question, guys?
Not in particular. I can see more options for MEP now than I did the last 2 times. But yeah.
When you have idea, then bring us up so we can also discuss. But it's good that you get the idea.
Yeah.
All right, guys.
From structural side, there's many possibilities.
Without
surface, you may, because it would be very, very difficult with some other software to extrude the lines which will present the members inside the software or those kind of surface. Many software are not capable to match those surface, and it's very nice because you can downgrade the curvature and take it out in software.
Exactly. Let's just imagine this is one of the molding, I don't know, that works for the stairs or I don't know, whatever structure, and we can analyze now using sophistic or durable RFPM for this particular geometry, which you would never model in like simple structural analysis modeling tool in reality. Okay, guys, thank you very much for today Rhino session. We'll continue with RFM after maybe 10 minutes break. If you have question, let me know next time. Otherwise, wish you have a nice weekend.
Yeah, thanks.
Thank you, Ingo. Thanks.
Thank you.